Okay, let's continue to process the lost data in this section. Okay, our agent here is already on the list, and it will continuously receive data here. Then at this step, when it finally completes, there is no data left under its content. There is no data at all. In fact, the content is empty like this. So why are we still processing it here? It's because we hope that only at the very end can we obtain the entire header information. That is, we only give it the entire header information at the very end. First of all, we must check for errors. That is, if there is something in our error data, it proves that this stream has encountered an error. That is, the error response of the stream data is processed here. As long as there is data in this error stream data, then we process it here. So first, we prepare a layer. We transcode it first, because it UTF-80 encoded. Then we convert this thing into our error stream. Convert to the stream. After converting, 望海大海域器正 create a read stream. Then we go deserialize it. Here, if deserialization fails, it means the JSON parsing failed, right? Then we directly call, saying there is a problem here, that the JSON actually failed to parse. This should never happen. We can take this part, copy this over. This is called RSP, ask. This part is generally not wrong. If there is an error here, the incorrect information is quite serious. So here we still give a warning. This is a problem with interface resolution. Okay, then if the interface resolution is normal, we need to check whether it actually comes from our error information. Then we prepare a RSPI-info. Then this error info, we should be here. It should be this thing. Error message. Note that there is one like this, a concept of level 1 and level 2. Make sure not to confuse them. You can see this place is actually one of its secondary data, secondary error message. Okay, then we connect this segment, connect this previous thing of ours. It proves that we can succeed. We will connect this and parse it back. Then here we still prepare our respite info. Assign this value to complete a corresponding assignment. Then we copy the original information over, and at this point, we log the log. After all, it has an error, right? If there is an error, we log this log. Of course, this is just a normal error because this error occurred. There may be many reasons. Maybe you don't have enough money. That token has run out of credit, or the account password is wrong. This kind of error is quite normal because it doesn't affect our entire interaction framework. So just throw a warning here and then spit this information back. And then if there is an error overall here, if there is a loss or error, it's here. We go down to the following, it should be here. So here, this loss, if it is normal. Normally, we just return our stream final information, and this part is actually not recommended to nest so many if-else statements. But we have already nested them. It should be fine. Because it is, after all, a bit complex. This logic, since we have integrated everything together, so it is a bit complex. This is pasted incorrectly. It should be this one. Let's switch back. Okay, back to here. Okay, so we prepare such a piece of information. So here we do the same. Should we get these 4 black dots first? Our 4 headers, because only at this point can we get this header. Then we assign a value to this total string. Then our final information is integrated. Similarly, we prepare something like a respire info. Then this respire info should be it. Then we reset these values in the string. And at the same time, we also complete the corresponding assignment for this message and total string. After the assignment is done, we just need to call the execution pin at the end. Okay, so basically we have finished writing it. Now let's compile it. There shouldn't be any issue. It's quite difficult. This is really quite difficult. Basically, once you master this set of HTTP, if you want to expand further, then you might need to encapsulate the underlying HTTP yourself. Label queer, that is, you look at how Unreal's cross-platform HTTP is encapsulated, and then you need to encapsulate it yourself. Generally, I think HPG has already gone quite deep at this level. Okay, so here, we give it a stream. give it a stream. Okay. Then when we print here, we can do this. We'd better give a stretch. And here we give it. It's a no. Because now we are losing. Or we give a ping. So we know which pin it came from. Otherwise, it's a bit troublesome. Because you need to know which pin it came from. Okay. This part is the feed. And here is the update. Okay, we are updating the pins here. Okay. Then we put this thing here. Alright. We don't care about these structs. Don't care about them. These are all cliches. Okay, so let's take a look at this. Let's call it and see what result we get. Now we execute, but we have a breakpoint. Hey, look, the breakpoint is triggered. Then you can see this thread is at manager. So yeah, 2 times here, right? Let's take another look. Okay, you can see this place update. The last update is empty. This is normal. Then this part is gone. Okay. Because the last one is empty. You can see the whole assembled result. It looks like this. So this empty one, we can do some processing on it later. But actually, it doesn't matter if we don't process it. You can see the data parsed each time. What we sent should be in segments. This is the original Y straight call straight. You can see it. It is data. It looks like this. You might say, can I directly parse it every time I receive it in a stream? Can I just parse it directly? I won't do a recursive judgment processing. Unfortunately, I tell you, you cannot do that. Because a problem will occur at the end, which is it might get connected together here. Meaning, there will be some issues here. You have to do it character by character like I did. To make a judgment, we can try some others. Give it a try. Hello, who are you? Then we give it we make a Node.js here. We see we didn't write a comment. Write a special comment just for direction. To make it easy for everyone not to misjudge this word. Because you misheard it, it might not be recognized. Okay, so here we give a copy of this paragraph over. Hello, I am a language model. And here we are. Okay, now let's add another one. Add another one, meaning we make a simple thing. Okay, here we ask another question. What do you think? Are you with Unreal Engine? How is Unreal Engine? Okay, let's first take a look at whether this result is satisfactory to us. Okay, let's press 1. Alright, okay, this one has an error. Let's see what this error is. What it indicates here is that the error message means that this row of message, all the index in message must be absent. This might be where we have the order written incorrectly somewhere. Let's check again. Very good, very good. This kind of error message is very good because you can see, can we also receive this response error here? You can see this blueprint information tells me. So this error is very simple. It's that I misspelled this word again in front of everyone. This is very normal. I understand. Okay, let's do it again. Good. See, it's no longer losing interaction. You can see, right? Good. Basically, we're done here. Then you can see this side. I should press it again. It should be fine. You can see. Look at this update. It's data. This data follows right after. But the last time, this update is empty. We can actually handle it. It should be fine. This is nothing. Okay, so basically, this lost interaction is now complete. In this chapter, we will conclude our discussion here. Okay, that is to say, if you are not using version 5.1 or 5.2, writing this thing will be quite troublesome if you don't have this delegate and you want to follow its approach. It will also be troublesome. So what should you do? Actually, you still need to look inside the HTTP where you can, this is how it works. It seems that is, it can go, that is when it receives data with when it receives data, we can see here, it seems we cannot click this point. Yes, you can see there should be a proxy here. That is, it can receive data at this location. Then every time you receive data, you should also be able to retrieve this data. That will be this approach of using a proxy. Originally, it might have been possible to do it this way. Yes, that means when there is no lost proxy. He has a proxy for receiving data, and then you receive the data each time you receive it. When activated, get all the data he has already received. Then, with all the data, then do some corresponding judgment and parsing. This should also be possible, but it might be a bit more troublesome. So using 5.3 or 5.4 is fine. Okay, this chapter is finished. Thank you all as well.